for being here for the last talk. I'm an assistant professor at Boston College in the marketing group, and I'll be presenting this work, Chasing Stars from Strategic Responses to Online Consumer Ratings. So in general, we know that consumers pay a lot of attention to ratings. There's extensive research on this. You can click. But what hasn't been studied as often in the literature is how often firms pay attention to the ratings. So you can progress. And so I'm going to be looking at how firms proactively try and change their ratings in a service-based setting. So my research questions are, first, do firms respond to their online ratings? And that, do they engage in certain strategic activities to influence their ratings? And do these activities vary the quality perceptions in the market or actually change the distribution of quality available? And then second, how do the way these ratings are displayed vary incentives for firms and change consumer welfare? So why do we care about these questions? So I'm basically measuring if firms are sort of gaming their ratings. And I think there's a lot of broader implications with this question. So first, there's misaligned incentives between consumers and firms. What I mean by that is that a consumer is likely looking for the highest quality firm they can find, and a firm's trying to appear to be the highest quality they can. So in that sense, there could be a misallocation of effort on the firm side, and that instead of investing in their inherent quality, they're just investing in their ratings, but not actually their true quality. And lastly, ratings might serve to homogenize firms. So we might start viewing firms as being in a 4-star bucket or a 5-star bucket, and we ignore other things that differentiate the firms. So a quick preview of my results. Actually, I'm going to skip this for the sake of time. You'll see the results when I get there. So now I want to walk you through my particular data and my context. So I have transaction level data merged with ratings, and it's in the auto repair market, which I think is a quite interesting market to study ratings. So I have data from 3 sources. First, my main data provider is a third-party platform that you can think of as kind of being like Yelp. And through them, they collect invoice data from auto repair shops. So I'll see, for example, in a given line of the data, I'll see that Joe got his brake pads replaced and he spent $500, and this is the type of car he has. The platform also solicits surveys and ratings. And what's really novel here in the data is I can match this to the invoice. So I saw that Joe went to Bob's Auto Shop on Monday, and then he left a 4-star review on Thursday, and I can link these two, as can the auto repair shops in the data. But I also supplement with Yelp ratings because they're sort of more popular to view. So I'm sure you're all familiar with what Yelp looks like, but just a reminder, here we have the auto repair shops where you see the number of ratings they have and their star rating rounded to the nearest half star. So I'm going to be using this rounding rating coming up. So just to demonstrate that, each shop has an average rating, and then at these certain rounding thresholds, they'll be rounded up or down to be displayed differently to consumers. So at 4.25, if the shop's average rating is above that, they'll look like 4.5, but just below, they'll be 4 stars. So how do firms actually respond to their ratings? So even though auto repair isn't sort of the most tech-savvy industry, I chatted with several auto repair shop managers in the data and asked them how they were paying attention to their reviews. And they overwhelmingly said yes, they were paying attention. So one said they respond to all reviews. They also say they track and have a service that updates them when their reviews are updated. So to kind of walk you through the sort of intuition behind this, consider that an auto repair shop has an average rating of 4.2. So they're going to be displayed as 4 stars because they're right below that 4.25 cutoff. If they only have 5 ratings, getting one more 5-star rating will push them past that cutoff to be displayed higher. So the next time a consumer walks into the auto repair shop, the firm will have to decide whether to take some sort of costly action to improve their rating, which will hopefully then increase their long-run revenue. But in doing so, they're giving up some revenue this period. And I'm only going to be considering strategies or actions that a firm take occasionally due to the way ratings are displayed, not a permanent long-run action. So I'm going to consider 2 types of strategies. The first is that they might actually refer away certain types of consumers or certain types of repairs that have given them poor ratings in the past. And the second is what I call the extra effort strategy. So the mechanic's going to do something to encourage the consumer to leave a strong review and to leave a review at all. And the way I'm imagining this is a hypothetical graph is that the closer a firm gets to these rounding thresholds in terms of their rating, the more they're going to take on these strategies. But when their average rating is sort of in a safer rating state, they'll back off because they are costly. So the first strategy of rejecting repairs, you might actually wonder, do people actually do this? And there's evidence that this happens in other industries. So in this 2018 Telegraph article, it says 1 in 3 heart surgeons refuse difficult operations to avoid poor mortality ratings. Now, auto repair is not as dire as heart surgery. But again, when speaking to the mechanics, they strongly hinted to me that they did this. So for example, some said that they can't deliver what the client's expectation is. Another said that they often have a bad interaction with the customer right from the start, so there's no point in taking on the job. So to check if this is happening in the data, I'm going to use that novel feature that I can link an invoice with its actual rating. So this will allow me to classify a repair as being risky for that particular auto repair shop. And I'm going to classify it based on the type of repair and the car type, which I kind of view as the type of consumer. So I'm going to define risky as anything that's not a 5-star rating, because that's the modal rating left in this data, as is true in most ratings literature. And then I can quantify the proportion of risky repairs a shop takes on, depending on their rating state. So this is sort of what the regression looks like. So I'll look at if the rating is less than 5 and look at the top 200 repairs or the car models with fixed effects for the shop and the time. And then I can see the percentage of invoices that month that the shop performs that have a risky repair. And then I can look at how this varies depending on the shop average rating and how far they are from those rating rounding thresholds. So what I find is that the further away a rating moves from a discontinuity, the greater the share of risky repairs it takes on. Another sort of analysis that I didn't include here is upon getting a less than 5-star rating on a particular repair, they're going to do fewer of those repairs. So kind of looking at it 2 different ways, we see that they in fact do take on this strategy. So the next strategy of the extra effort strategy. So this one I can't directly observe in the data, but I do have descriptive evidence that's happening. So for example, if a shop's average rating is close to those rounding thresholds, there's a huge increase in the number of reviews being left, about a 25% increase. And in fact, around the threshold for a 5-star rating, it's almost a 50% increase. We also see this graphically in that there's an excess of massive ratings just above the rounding thresholds. So to see this graphically, on the x-axis, we have the average rating normalized to the closest rounding threshold that rating is near. And we see there's a huge peak just to the right and a huge trough to the left. So somehow mechanics are able to sort of encourage consumers to leave reviews right when they need them the most. Now, because when consumers leave reviews, they leave them in full star ratings, the data is discrete. So we would expect to see some kind of funny distribution like this in practice. But when I simulated reviews, if they were independent, you can click one more. We see in the pink, that's what we would expect the data to look like. But in practice, we actually see about 1/3 less data and 1/3 more data than we would expect. So again, this is some descriptive evidence that the firms are able to do something to get consumers to leave more reviews. But I imagine that it's costly. It could be actually monetarily costly or just costly in terms of time or mental bandwidth. But because I can't directly observe when it's happening, I need a model to back out when it's happening. So in the structural model, there'll be an auto repair shop with a certain displayed rating, an average rating, and a number of ratings. Then repairs will arrive at the shop at rate lambda star, where lambda is increasing with their star rating, and that's just calibrated from the data. And then when a consumer walks in, the shop will have to decide if they're going to exert extra effort. So they're going to get profit pi from the repair, and if they exert extra effort, they have to subtract away cap by the cost of that effort. Then a review will be left at rate PR or not. And on the consumer side, they'll see the displayed rating. They'll choose which shop to go to. Then they'll see, upon getting their car back, they'll figure out how much effort they received. And then they'll decide whether or not to leave a review and what star rating to leave. So the goal of this model is to calculate optimal policy functions of when firms should be exerting extra effort, to estimate the cost of that effort, and then to look at counterfactuals of what would happen if ratings platforms displayed ratings in different ways. So I don't go through the details of the model or equations for sake of time, but the parameters are structurally estimated are the probability of obtaining 1 star with no effort, which is about 38%. Then the change in probability of obtaining 1 star with effort. So the probability of getting 1 star decreases by 31% if you engage in extra effort. And then the cost of effort, which is 11% of profit. So it's not the majority of profit, but it's a substantial enough fraction that firms should care. So I find that this strategy is important for firms to do. So for example, if a firm only has 5 ratings and they're right at that rounding threshold to be displayed as 5 stars, if they never engage in this strategy, they can lose 25% of their future firm value. And even with 50 ratings, they can lose 1% of their future value. So here on the x-axis, we have the number of reviews a shop has. And the y-axis, we have the percentage of rating states in which the shop should exert extra effort. And we see that up until about 25 reviews, they should always exert extra effort. And the more ratings they have, the fewer rating states they need to exert this extra effort. You can go ahead and click several times. So this one's kind of flipping it to the opposite, where we're looking at the average rating state and then whether or not they exert extra effort. And the lines will be different number of reviews. You can click a few more times. And as we see the shop gets more and more reviews, there's fewer and fewer states that tend to be really far away from those rounding thresholds in which they need to take on the strategy. Yeah, one more. So then using this model, I have some counterfactuals. So first I considered the counterfactual where ratings aren't rounded. So they're just displayed as the average rating. And this intuitively, I find that firms' incentive to exert extra effort increases. So effort is observed up to 30% more often. And that's because any additional rating and rating change the consumer will now see. If you look at the opposite, firms' incentive to exert extra effort decreases because now there's sort of more areas in which the consumer doesn't view the actual average rating. They're sort of farther away from the rounding thresholds. And so while there's a lot of potential, like different consumers might have different reactions to this, but if you kind of combine them together, it suggests that rounding ratings can be lowering consumer welfare because they're not receiving this extra effort. I also look at the counterfactual of weighting more recent reviews, which was suggested in a theory paper by Boulder in 2020. And the idea of this is it helps lower barriers of entry, and it also discourages firms from resting on their laurels, because once a firm has 100 ratings, maybe they kind of stop caring about their quality because their rating's pretty fixed. But if we weight more recent reviews more heavily, then they continuously have to care about their reputation. And here I see that effort occurs up to 94% more often. So I know I'm wrapping up in 1 minute. I know we're over time for the full the session. But in general, I provided descriptive evidence of how firms work to increase their ratings. I presented 2 channels through which they improve their ratings. And I developed a model of how they should strategically respond depending on their rating state. And one more. I think that this work and the counterfactuals begs future questions about how ratings platforms should be designed in order to align incentives between consumers and firms. So that's all I have. Thank you.
Thank you. Okay, Chris, I think we do have time for a couple of questions, right?
Yes. Any questions? Yep.
So my question is, what's happening on the consumer side? So a common reason people have mentioned about why it's good to have rounding rates is because it may incentivize experimentation for the consumers and avoid everyone herding towards one shop or another. So how can that be incorporated in your setup, or have you thought about how this trade-offs would play in your model?
Yeah, that's a good point. I haven't incorporated that into the model directly. I looked at just some descriptives of, for example, what happens on the demand side of, like, say that the shop's rating is like above the median or the average rating in that city or in that zip code, and kind of tried to look at competition that way, like how many other auto repair shops are there on Yelp in that city, and where does it lie in the distribution of ratings, and how that affects demand, because I do see, you know, the number of consumers that the shops get. But I haven't incorporated it into the structural model. I could see how it could sort of create like a cascade effect. So that's an interesting thought. I'll think about that more.
Are there any questions on the Gather platform?
So I actually have a question on your first mechanism, your first channel. I think the data is super clean, and it's, you know, hard to argue with, you know, seeing when they do or do not take those risky repairs. But on the effort thing, when you see this histogram with like a huge bump above zero, to me, frankly, it suggests not that they exerted some special magical effort, but I think a large chunk of that could be just fake reviews, right? If you're just like 1 or 2 reviews below the threshold, it's just so tempting to ask your cousin or someone else to put a review, and I'm struggling to see if there is a way to tell that apart from, you know, the effort story that you have.
Yeah, so fake reviews are definitely a problem, as we all know, on things like Yelp. So I see basically the same. I'm actually not, I don't remember if that histogram was from the Yelp data or my third party, but I see the same pattern across both platforms. And the third party data, I think, is much harder to have fake reviews, because you can only leave a review if you get an email from the third party after you visited the shop and then you fill out the survey. So I think that's a lot harder to fake, and I still see that pattern.
So that's actually super interesting, because I think you can, if you have both of these data sets, you can try to back out fake reviews. I guess obviously you need to think more about it, but that could be very interesting to be able to back out fake reviews and like see what it depends on and a lot of things by looking at the diff between the two. Okay, very cool.
Yeah, that's a good point. I can try that.
Okay, thank you, everyone. Let's thank the speakers, all the speakers once again. That's it for the